Hello, in this particular demo we're going to have a look at an example architecture. So this is the one that was sent out to everybody. It's going to provide one illustration of how all of the different components and pieces that we need to bring together to form a game, how we can potentially actually bring them together. So this is taking things like our the ability to detect input, to load graphics, to play sounds, to draw things to the screen, and to wrap them all up in a way that we have a good foundation on top of which we can start to realize whatever the elements and the things we have our game in terms of the game objects, what they are. There is an important, if you like, notional health warning with this particular talk. It does assume that you are comfortable with all of the component parts, that in terms of all of the other stuff we've looked at for how you get input, how you draw bitmaps and manipulate them, about components, fragments and views, that these are things that you are reasonably comfortable with. If you're not, there really isn't much point carrying on having a look at this, because the architecture is very much about how all of those different parts get to be combined together. And to understand how best to combine them, you need to understand, obviously, the component parts in the first place. So certainly, if you haven't explored the earlier stuff or not comfortable with it, wait until you've done that before coming to look at this one. There's actually quite a few classes that we're going to have a look at within it. I'm not going to. This is very much looking at the architecture in terms of the objects and classes that we have. Some of the later demos will actually show how we can use the architectural classes to provide a couple of very sort of crude and simple games, in terms of ones that sort of illustrate some of the platforming aspects, ones that illustrate sort of a top-down scrolling based one. We'll use that for illustrating things like steering behaviors. But for this particular talk, what we are interested in is the architecture, the underlying classes that make these two other demos possible. Also worthwhile pointing out that this is but one architecture. There's no such thing as a correct or perfect or optimal architecture. Rather, there's lots of different ways you can piece them together. Depending how you do it, there'll be certain strengths, there'll be certain weaknesses. Quite often I think it's useful to understand, well, what the strengths and weaknesses are. But it is one architecture. You're free to use whatever bits of it you want to use. You're free to change it, to modify it, to entirely throw it away. So we'll start off looking first of all, I suppose, at the heart of the architectural design. So we're going to have here a single activity that will contain a single fragment, and we're going to call that fragment our game. So effectively, that's the heart of the game overall. That one single fragment. The fragment will also contain a single view object. So it's a full screen view as part of a full screen fragment, part of a full screen activity. So it's a fairly simple Android mapping from activity to fragment to single view, and that's the basis under which we're assuming the game will be structured. What this means is that if we have different things within the games, like a splash screen or a menu screen or game screens we're all going to be drawing them to the same view. So we're just changing what it is displayed to the view to realize whatever aspects of the game that we want to do. Our main fragment, inside that we're going to have our game loop. So this is the thing that will keep the game ticking and updating. And we'll have a look at some things about how we do timing in a second. Also within that main fragment, we've got all of the managers, the things that sort of make the game possible. So we'll have something for loading in stuff from the I/O system. We'll have an asset store for storing all of the assets that we want to have. We'll do an input manager for looking after inputs. We'll have a renderer for being able to draw the games and draw to the screen. And we'll finally have a screen manager, and this is the thing that will contain for example, the menu screen, the option screen, the game screen, whatever's relevant to it. So at our highest level, that's the structure we have. So we'll have a look at some of those particular classes. So there's the main activity class. This is the one that extends activity. In terms of how it is set up, we're basically configuring the window to a good game-related one, setting the content view to be the single fragment, adding that fragment in and creating it. The main game class, which is probably by far the biggest class here, it's very much the heart of the game overall. So within this here, it extends a fragment. We have a few properties within this here. For example, these are some things about the number of frames per second that we're trying to get out of it, and we can set that up, get the average. We will define all of the managers or the services. So a game needs to bring together a number of things for getting input and loading stuff and displaying stuff, and all of those notionally need to live within a single point. So the single point that they live in for us is this game class, which also happens to be the fragment as well. So the game fragment, it contains the asset store. We can get that. Now, the reason we have get methods here, for example, for the asset store, is that there's lots of different objects that may want to either add things to or get assets from the store. So if we have a player object, the player object may want to get its animation from a bitmap that's been loaded into the asset store. So we need to have a way, not of changing it, but of sharing the asset manager or the asset store with whatever fragments or game objects need to use it. We've got a screen manager, so containing the different screens in the game, we can get that. We've got an input manager, we can get that. File manager, and likewise. We also have a render surface, and so we have a single view that we're drawing to, but there's different ways that we can draw to that view. We might be using, for example, a canvas type of object. We might be putting in an OpenGL renderer to it. And we'll talk about that in a little bit, but wanted to design this in a way that we can sort of plug in the rendering component that you want. So it's going to be an interface that will enable us to draw, in whatever way is appropriate, to the view that we have available. We also got our main game loop. This is the thing that will measure how time is elapsing and trigger the update on the draw ticks. Some information here about the screen width and the screen height. So the fragment is going to be full screen. It will work out how big it is, and then it can report that to objects that need to know the screen size. So that's all the main elements. We've got our onCreate method. So we're creating here the fragment, and we've got our onCreate view method. So we're using or overloading both of these. So the onCreate, we're going to create as many things as we can. If there's something that needs the view, so for example our input manager, we need to register, say, touch events with the view. We can't create it until we actually got the view, so we'll leave that to onCreate view. Here we're creating things like the main loop, the file I/O, the asset manager, the screen manager, and we're setting the volume control up for this particular fragment and activity. So they're all things that are not dependent on the view. On the onCreate view then, we're creating a new renderer, so we can draw to that view, and we'll see, we're going to use a canvas renderer initially in this one, but you can plug that in with a different one if you wanted to. We get our input manager, which is linked to this view, and at this point we're actually going and getting some display metrics to work out how big the window is, and we're storing those for other things to use. So once onCreate and onCreate view have run, we've instantiated all of the major systems that we have within the game. We've got some resume and pause componentry here that will pause the current screen, pause the game loop, or resume it, or whatever is appropriate. If we're deleting things, then again we'll make sure we give our screens an opportunity to dispose of themselves. We have our central update and draw methods within this particular class. So it is the fragment. The update and the draw method will be called by our main game thread. So the game loop's going to be going around measuring time, and at X number of times a second it's going to go to the particular game class and say, okay, well, can you update the game, or can you draw the game? And I'll talk a little bit as we go through this about how we do that. But effectively, here's the doUpdate method that the game loop will call. It's passing in some information about the amount of time that has elapsed. And then we are updating some input. We'll talk about that in a little bit. We're going to our screen manager and saying, well, what's the current screen? We might as well update this screen too. So there we're updating the things we need to update, and we're notifying the game loop that our update is finished. And down here we're applying the notification. When we're drawing it, all we are drawing then is we're going to our screen manager and we're saying, okay, give me the current screen. Is it the splash screen? Is it the menu screen? Is it the game screen? What one are we displaying at this point in time? We get it. And we then go to our render surface and we ask it, okay, can you take this game screen and draw it to yourself? So this is at the heart of the game where we actually are triggering these different aspects. And again, we don't have a notify here. This is a sort of a distinction between it. So we're assuming there that when we do our update, when we're finished the update at the bottom of this, we're going to notify the game loop. And you can see the comment there that it's assumed that if we have a multi-threaded update, that it will block and is only going to come down here whenever we've done the update. For the draw, we don't have a notify visible in this chunk of code. So the assumption here that we're making is that the render surface, it is the one that's going to come and call notify whenever it is finished drawing the game screen to itself. So the reason we do that is that we want to have a lot of control given to the render mechanism, and there's different ways of doing it, so depending on the render mechanism we may want to call or notify at different points in time. So what we have underneath this then is, you could actually take this out as a separate class, it's coupled in here tightly to it. So we have our main game loop, it says runnable object. We're using Boolean locks here, I'll show you that in a little bit underneath about controlling access to update and draw. We've got some timing information. Now, let me just show you where we have our timing information, if I can remember whereabouts it is. Under engine, elapsed time, there we go. So the game loop, every single time it does an update, it's going to package some timing information up within an elapsed time object. And all this it embodies two pieces of information. One is the step time. So this is how much time has elapsed since the last time the update happened. So if we're running at, say, 50 frames a second, then this will be sort of a 20 millisecond period. Total time is the total time since the game first started to run. And we provide these two different measurements because sometimes you're interested in just an absolute measurement of time, like your total time, and sometimes you're only interested in, well, how much time has happened since the last time I was called. By packaging both of these things together, it means the game loop can pass this off to whatever objects need it. So it makes those objects a little bit more easy to do their operation. So we have our elapsed time that we're updating. The game loop then is very similar to the previous one we had a look at, so if you want to go through that, you can have a listen to it. The only real difference in this one here is how we deal with things like synchronization. So there we're using a Boolean lock, so this is something that will be set to true or to be false. The synchronized keyword, it makes sure that there's potentially going to be a number of threads that are accessing or modifying this variable. So we could have our main game loop that's sort of, okay, checking to see here is it true or is it false. We could have our sort of our fragment running in a different thread, the UI thread, checking or updating it too. So the synchronized keyword, it basically makes sure that inside this particular block, this is the only thread that is allowed access to the update object. And if another one tries to leap in while I'm accessing update, it will be blocked until I'm finished. So we say that update, is it locked? We say to be true. So in other words, we're in the process of performing an update. We then go to our main game and we say, well, can you do the update, please? So it'll go ahead and do the update. We synchronize again and we check to see, is update locked? Now, whenever we call the update thread and we come back here, if the update takes a few milliseconds, we're going to hit here before the update is finished. And what we're going to be checking to see is it is locked, then we will wait. So all objects can be waited on. And that will block this particular thread. The thread will stop here and it's going to wait until we are notified. So if I'm waiting at this point and I have another thread come along and call the notify method, we will then be notified that, oh, update has changed. We've made an access to it, we've modified it. So at this point we will be woken up and we can carry on then. So this is our synchronization mechanism that we use to control the operation between these two different threads. Exactly the same with draw. We set it to be locked. We then say, okay, do a draw. We will then wait on it. And whenever the draw has been finished, we'll be notified. And at that point, we'll carry on our operation. So it's simply synchronization at this point. Working out our end time or sleep time, go to sleep as long as need be, and so on. So the rest is the same as the other example. Now, that actually covers the heart of this particular activity here in terms of all of these classes over on the other side. So let's now have a look at the ones we have over on this side. We'll start off first of all with our screen manager. And this gets into the idea of the world within which we're playing our game. So we're assuming that the screen manager contains a number of different screens. And we might, as mentioned, could have a menu screen, an options screen, a high score screen, a game screen, a level 1, a level 2, whatever number of screens that you want to have. And at a point in time, we'll be updating and drawing one of those screens. A game screen itself contains a number of game objects. So these are objects we have within the game. And the idea is you have a specialized range of these here. So you might have a sprite as a moving object. You could also have a menu button. So you could have a button as one of your game objects as well. You could have a high score, again, as one of your game objects. So game object is our underlying type. It's the basic object that resides within our game as part of a screen. And we can create as many specialized types as we want to, depending upon what's appropriate for the game. So that's the model we're assuming. We're also assuming that a game screen can have a viewport. So this screen may be bigger than the physical screen we have available, in which case we can declare a viewport into it. Which bit of the world are we seeing? And if we want to do things like a sort of a split screen view, we can also declare a screen viewport, which is the bit of the screen that this viewport or this game screen writes to. So we'll have a brief look at some of the classes that's in the world class here. So we have them there. So if we went to, actually just do screen manager first of all. So this is the one that resides within the game. It's quite straightforward. We've got a map, a collection of game screens, and we're calling them or indexing them by name. So I can go to my screen manager and say, give me the game screen called main menu, and it will pull it out. I also have a variable for the current screen, the one that's active at this point in time. So I have methods for adding in a game screen. I make sure I don't really have it. I have also methods for setting what the current screen is, and methods for getting out the screen, or getting either the current screen or the one by name, and methods for removing the screen as well. So it's a simple container enabling me to add and to get things out from it. The game screen itself, now this is an abstract class, so it assumes that you would take this and you would build upon it to make whatever menu or game screen or level screen that you want to do. So this is quite a simple class as well, intended to be extended and built upon. So we give it a name. What's the name of this screen? This is important. We've got here a link into the game, and we can get that out. And whenever we construct a game screen, we say, what's the name of this? And also, what game does it belong to? This is an important form of linkage. If we think about our main game class, so that's one we had a look at, it contains the asset manager, the asset store, it contains the file I/O, it contains the input, it contains the renderer. So all of the things live within the game. And it's perfectly reasonable to assume that, for example, if this is a menu screen, it'll want access to some of those components. Or you could have a game object that wants access to some of those components. So by saying that when we create a game screen, we store the game within it, it means that we have a way of accessing our main game. So in my menu screen, I can go to this particular property, my game, and I could say, okay, let me go to the game, let me get the input manager, let me check something with it. So this is our link back to the main game and our link to all of the services then that the game offers. Beyond that then, we've got a couple of abstract methods. So you can update your game screen, and you pass in here your time, and you can draw your game screen. Again, we're passing in time in case we need it for animations or something, and we're saying, okay, what we are drawing to. In this case, it's graphics one. We'll talk about that in a little bit. So they're both abstract because if you're writing a menu screen, you'll update it and draw it differently than if you're writing, I don't know, a game screen or a level screen. The bottom of them get pause, resume, and dispose. So they're not virtual or abstract methods because you may or may not want to overload them depending upon the screen you're using. And you'll see, and I'm not looking at them here, but for example, when we go down to some of the other ones, and we do have a screen, it will be extending our game screen and then adding in whatever is sort of specific to that particular screen, but that's for another day. The game objects then. So a game screen contains a number of game objects. So there we can see it's a class. It belongs to a screen. So again, that's important. And whenever we are creating our game object, we say what screen it belongs to. What this means then is that each game object can get access to the screen to which it belongs. And because it can access to the screen, it can also go to the screen and say, well, can you give me access to the game? So each object through the screen can get access to the game, and hence can get access to all of the different managers and services that we have available within the game. So this form of linkage is important by way of sharing, if you like, the central functionality that the game offers. Other things, these are some arbitrary decisions. I'm assuming here that each game object is represented by a bitmap. It's a reasonable assumption for a large number of game objects, not for all game objects. Some game objects may use a completely different representation. So that it's an assumption that I've put in. It works okay for the types of games that I'm thinking of creating. But if your type of game has an object that doesn't have that, then again you can tweak or revise this particular class. We're saying all game objects have a position and have a bounding box that surrounds them. And again, this is another assumption. Here we're assuming that it is a box that surrounds things. Maybe it's a bounding circle. Maybe some things don't have a bound. So we're putting in assumptions here. And it's important to realize that they are assumptions about the type of game world that we're creating. And if they don't meet your needs or your requirements, then break those assumptions. Take it out. When we're drawing, we will want to create rectangles to enable us to draw to the screen or to draw from our source bitmap. Now we don't want to keep creating rectangles every single time we draw. So here we're defining them and going to reuse them as part of the draw request. Got a method here for creating it, a few constructors depending on what we're passing in. And we've got our bounding box, we can get that, we can get the bitmap out, we can set the position. All game objects have an update, so by default our game object does nothing, but if we're extending this to be, for example, a button game object, then as part of our update here we get our input manager and check to see if somebody's touched this and things like that. If we're drawing, again we'll come back to drawing a little bit, but here we're using some of the helper classes, working out, okay, I'm going to draw this time using this graphics. Here's the layer viewport, here's the screen viewport. Okay, let me draw myself out, but we'll look at graphics in a little second. That's probably all we want to say for this here. The layer viewport and the screen viewport are similar things to what we looked at when we were looking at viewport. So these are simply nice helper classes that encapsulate, an X and a Y position, a width and a height for the viewport. And have some methods then for getting these things out, or working out if a point falls within the viewport, or if a particular bounding box goes in the viewport. So all of those ones, they tie onto the viewport talk, so you can sort of understand them from that perspective. Right, so that covers that one. Next one we'll have a look at is the asset store. And the asset store, this is the one that stores all of our assets, our bitmaps, our music. It makes use of the file IO. And so it's for loading things in, and we can add and retrieve things like music, sounds, and bitmaps to it. So if we have a look at that, we have our asset store. Actually, just go through file IO very quickly. This is
very similar to the one that we looked at earlier on, the earlier stuff, for loading in bitmaps, or loading in music, or loading sounds. So not really any difference to that. The actual store itself, it is a collection of maps. Okay, the hard one is hash maps, but a collection of maps. So we have one collection of bitmaps, which we can refer to them by name. We have a collection of music objects, refer to them by name. Sound objects, refer to them by name. And the music and sound objects here are the same ones that we looked at earlier on within. And we've got a sound pool for storing any of our sound effects. Create our asset store, we create all of these different ones. And then beyond that, we simply have a bunch of methods where we can add in, for example, a bitmap, give it a name. We can add in music, we can add in sound, or we can load and add in a bitmap. So if I say, here's the name, here's where it's found, then the asset store will go to our file IO, load the thing in, give it the name, and add it to our store. So this is basically a class that's intended to help us load in and to look after all of the different resources that we have. Down at the bottom then, we have our bitmaps. We can get a bitmap, get music, get sound. These are the ones we retrieve it. So the idea here is that whenever you, for example, create a game screen, you might, as part of the creation there, load in all of the graphics that are used within that game screen. And whenever you're creating a game object, you may have multiple instances of this game object. The game object, if it needs to get access to particular graphics, would say, okay, let me go back here to the game, let me get the asset store from the game, and from it, let me retrieve the bitmap. So all of the assets live in the store, so we're only storing them once, and different objects can request access to them as and when they need them. Now, there is one component we want to have a look at here in terms of the asset store. It is reasonably simple and reasonably straightforward as it is defined in this case. If you want to get fancy, you can get into things about, well, how you do load it, and if you load it synchronously or asynchronously. For a lot of the stuff that we're doing, we don't really need to stream the loading in. We're probably not going to be loading a vast quantity of stuff, so we simply can load it in at the start. If your game ever does get to the point where you're loading in shed loads of stuff, then you probably will want to have a separate thread that loads it in the background and then sort of talks to your asset store to say, okay, I've now loaded this in, I've loaded that in. So there is some sophistication you can add in to it. Next up, we'll have a look at our input manager. We've got a central class, and it's going to use a number of different helper classes. And again, these are all things that we looked at in terms of accelerometers or getting key input or touch input. But it does present us with a particular problem. These are events that occur. So as I move my finger, for example, over the screen in a touch screen, I'm generating a load of touch events. And all these events are coming in and being passed in, for example, to my touch handler, and it's saying, oh, there's another touch event, there's another touch event. So it's recording them. That's good. So I want to record all those events. But if you think about it, we're using a game loop here, and the game loop is at regular intervals saying, okay, let's go and update our objects. Let's wait for a bit of time. Let's go and update them again. Now, there's two sort of stretches to time here. You can have your game loop every, for example, 20 milliseconds saying, let's update. And you have your input events coming in just willy-nilly whenever they come in. So for one particular frame, I might get 3 new touch events arriving during that frame. So I want to have a setup where my touch handler takes in all of the events and it just stores them. It accumulates all of them. But each frame, I can go to it and say, okay, can you give me the new touch events that have occurred for this frame? So then I get the events just for that particular frame. If you like, that's all of the input events that have happened in that frame. And I want to have a way of sharing those with all of the different game objects. So this is where we have then the notion of actually creating our own touch event, our own key event. So these are things that we will store, we'll create, we'll populate, we'll do it each frame, and that's the things that we will then share with all of the other game objects that want to have a look at it. So let's have a little look at how that is is implemented. So we're in our input class here. A few different things in this. We've got our main input class and then the different helpers. But actually, let me show you this one here first of all, because maybe it's an easier way of getting into it. So we have our main input service here, minput. We're creating it down when we create the view, because there we can add it into the actual touch handlers and things like that. And whenever we do an update, we are going to our input manager and we're asking it to, in this case, reset the accumulators. Now, what does that mean? An accumulator is something that accumulates events. So as our input events go in, they get to be accumulated, they get to be stored. So if we reset it, what it basically says is take all of the new ones, store them out as the events for this particular frame, and then accumulate any of the ones that come in after this particular point in time. So this is where we do the accumulation. If we have a look then inside, or actually let's do, for example, a touch event. So this is the type of class that we may have several of them and we'll pass them off to the game objects. It's a simple class. We store, okay, what type of event happened, where did it happen, and what is the pointer ID. So that's all that class does. That's all we're sharing. Inside our main input manager, it is the one that contains links to all of the different handlers. So in this particular case, we're interested in the touch handler. And this, if you look at the methods here, you'll see the notice you get touch Y, get a list of touch events. All we're doing is we're going to the individual handlers and we're asking them to do the work. So the input class itself is just simply a glorified interface onto all of the underlying handlers. And anytime we reset the handlers, we go to the touch handler and we say, well, can you reset your accumulators, and the key handler, and can you do the same, just in case there's multiple, say, key presses inside one frame. So let's have a look then at our touch handler. And this is going to be very similar to the multi-touch listener that we've seen earlier on, so I just simply want to point out what the differences are within this. We're going to have well, actually, I'll talk about the pull in a second. We have two lists of touch events. We have touch events which apply, which have been accumulated for this particular frame. So whenever I say reset the accumulators, I will create a list of touch events which have happened in this frame. So they're all the ones I'm passing off to the game objects. Now, I don't want to change that. I want to be able to go to my game objects and say, here's a bunch of touch events. They're not going to change. They're the ones that occurred for this frame. Process them as you feel free. Alongside that, I could be having new touch events coming in. So I've got them for the start of this frame, but subsequent to that, new events come in. And these are really going to be events for the next frame to process. So I have a separate list here of unconsumed touch events. So these are events that I will use in the next update. So I've got these two lists that I am maintaining. All of this then about the touch handler is the same as we had before. For extracting the stuff out, no difference at all. We add them in to our list of unconsumed touch events. And down at the very bottom, when we reset the accumulators, all that we do, and we'll do this once per frame, so once per frame we'll reset the things. All we do in this here is that we copy across from our unconsumed list of touch events into our list of touch events, and that gives us our sort of copy that we can pass off to all of the other objects. So this is simply the mechanism that we use then to keep having a sort of an accumulating one with new ones coming in, and then to siphon off one update's worth of touch events and share them out. The reason we have a pool, now pool is a class I've written myself. It's an object pool. It's actually in the util directory. It's a sort of template class. You can have a read of it or look at it yourself. The reason we have an object pool being used here is simply for performance reasons. Touch events, we're likely to get loads of touch events occurring. So as you move around it, there will be literally hundreds of these things generated.
we don't want to be creating loads of objects and then quickly deleting loads of objects. So I'm going to have a pool of reusable touch events that whenever I want to create a new unconsumed event, I will take it from the pool, and whenever I'm finished with my touch events, I will release them back into the pool so I can reuse them. And you see this one down here, that when I'm resetting the accumulators, the first thing that I do is I go through my list of the old touch events, the ones I had for the last frame, and I add them back into the pool. So I'm freeing them up. Then I clear my list of touch events for this frame, and I populate it by copying across the unconsumed events, and that gives me a way of doing the particular frame. Right, final thing we want to have a look at, and this potentially is one of the more difficult bits, potentially not, just depends on if you get the right viewpoint for it, it's not too bad at all. It's to do with graphics and how we actually want to draw the things out. Because I wanted to design this particular example architecture with a sort of a plug-and-play graphical side, that I could change the rendering component. Maybe I want to use a canvas initially, and maybe I want to then change to, say, using OpenGL later on down the line. I wanted to design it in a way that would minimize the impact on the rest of the game. So I could take out, for example, a canvas renderer, put in an OpenGL renderer with minimum hassle. The normal way you do this then is to define a set of interfaces which kind of abstract out one side being the rendering, how we actually do the rendering, from the provision of the ability to render. So I'm going to have two interfaces, one called a RenderSurface, and I'm drawing two, and then one called a Graphics 2D interface, which is what I can use to draw to that RenderSurface. And the idea is you can provide as many implementations as you want to. Here, for this example demo, I provided a canvas renderer as the example implementation. Well, you could take this out and you could put in, for example, an OpenGL renderer. So we'll have a look at how these different components fit together. So within our main graphics class, we've got our RenderSurface. So this is the thing we are drawing to, and it's remarkably simple. It's an interface. RenderSurface has a couple of methods. We can draw to it, and if we're drawing to it, the pertinent information is, okay, give me some timing information and tell me which screen I happen to be drawing to it. And I also have a single method, getAsView. Now, I need to get that there because this is an Android component, so it is something that is a view object within Android. So at sometimes, for example, within the fragment, I want to say, right, give me a render surface. From Android's point of view, I need to treat it as a view. Okay, so get me that Android, that render surface as a view object, so I can pass it off to whatever Android methods I need to use. So very simple interface. Within my graphics interface, this is intended to be a set of methods that if I call these, I will draw to my render surface. So I don't know what type of render surface I'm going to have. Is it going to be a canvas? Is it going to be a GL screen? It could be any of these. So because I don't know what the underlying render surface is, I don't know how I'm going to, for example, draw some text to it. How I draw text to a canvas is different than how I draw text in OpenGL. So I'm defining here a bunch of methods that say to my game objects, if you want to draw text, you can draw text. If you want to draw a bitmap, you can draw a bitmap. So I'm exposing the functionality that all of my render surfaces must provide, but I'm not letting the callee see how it is provided. If I'm going to use a canvas to do this, if I'm going to do it as a GL call. So again, it hides some of the details. And for this simple demo, I've only included a few methods within this. If you want it, you can enrich this particular implementation. Now, the two examples that we provide, and before we do this, let's just have a look at our game class. And we see how the render surface fitted into this. So down here we have the surface that we were drawing to. Now, I don't know if it's a canvas or I don't know if it's OpenGL surface, it's just a surface I'm drawing to.
In my onCreate view, this is actually where we have nailed it down. So this is an interface, and I've decided, okay, I need to create the view here, so I'm actually going to use the canvas renderer. It's the only one I have at this point in time. If I had an OpenGL renderer, I could maybe create one there. And you can see here that we need to return a view. So this is the onCreate view. So Android is saying, give me a view, please, you want me to draw to. So I need to be able to go to my RenderSurface and say, well, can you give me yourself as a view so I can return you, so we can actually draw on you. When we're doing the draw, here we're going to our RenderSurface of whatever type it is. I don't know, I don't care. And I'm saying, okay, draw please this game screen to you. So the interface, the linkage into the game is remarkably simple. We defined a reasonably simple interface and set of methods that all of our game objects can use or game screens can use, but we're hiding the implementation behind it. So actually, let's have a look at one of those implementations. So we'll do our canvas RenderSurface first of all. And it extends view, so it is actually is a type of Android view, and it implements this interface. It has to do that. Down there, we're going to have a canvas graphics 2D object. So this is something that's capable of drawing text or bitmaps to a canvas. We've got our link to the game, so this is important because then we get a link to anything else we need access to. We also got our link to the activity. I mean, if you get it through, you can also get it through the game if you wanted to, but there we're storing it directly within this. We are remembering the screen that we want to draw, and we're remembering the elapsed time information. So when we create the RenderSurface, we're just simply storing these things and creating a new graphics object. If we're getting as a view, all we're doing is returning ourselves. Because we are a type of view, that's all we need to do there. And here's the interesting methods. We've got our render method. Now, as a reminder, our game loop is going to go to our game, and it's going to say, well, can you draw yourself, please? And the game is going to then go to our RenderSurface, which is this class here, and call the render method. And it's going to say, right, I want you to draw to yourself, here's some timing information, this particular screen. So this is where we take the story off from. Now, you'll notice here, we don't do any drawing. What we do is we store the time information, and we store the screen that we want to draw, and we call post invalidate. So what we're using here is actually the canvas render that we looked at in one of the earlier lectures, that we want to use the UI thread to draw it out, because then it's hardware accelerated and it's going to be faster than calling it from this thread, which actually is going to be triggered from the game loop. So by doing post invalidate, what we do at this point is that we say to the UI thread, can you draw the view please for me? And we post that message in and it'll get around to drawing it. Now, you'll notice that there is no notification at this particular point. There is notification on down, but when we call the render method, we'll invalidate it, and we'll then sort of exit out of this. We'll go back into our main game loop, and we'll check to see is it updated, and it'll still be false. We'll pause at that point. So post this here, effectively we're going to pause the UI or the game loop. This method, when we do the post invalidate, this method will then be called at some later point. It won't be too far in the distance, but it'll be called. It won't be called by the update game loop thread, it'll be called by the UI thread. So it's going to be called by a separate thread. It'll say, okay, you want to draw the view, I'll give you a canvas object which you can use to draw the view to. So then we're going to our graphics object, and it's a canvas graphics object, so we need to store the view. I'll show you that class in a second. And we go to our game screen and we say, okay, game screen, I want you to draw yourself. Here's some time information. Here's a graphics object that you can use to draw yourself with. And at that point then we're actually getting the game to do all the hard work, working out how each of the objects needs to be drawn. Once we finish doing the drawing, at that point we finally notify that we have concluded the game.
and that will then actually trigger the game loop. It'll wake it up if it's waiting on the notification, and it'll then carry on with the rest of its processing. The actual graphics class itself, very, very straightforward. It has a canvas, we're passing that in, remember, just there. Has an asset manager, we're going to use it at the minute. And for the implementation of the methods, for example, drawing a bitmap, different types, drawing some text, you can see there all we're doing is we're calling the corresponding canvas method. So if we're using a canvas, it's very easy to draw these things out. If it's OpenGL, then we'd have to put in here a series of OpenGL calls to appropriately draw the bitmap. But that's it. It can be a little bit hard to get your head around what's happening there because we have different threads that are being reasonably sophisticated in how they're talking with one another. But it's useful thinking about this, writing it down on a piece of paper, trying to sort of sketch out what you see as been happening. But that's a little bit of complexity on it. Now that's all I want to say about the architecture. Just to reiterate, it is reasonably complex. It's tying together a lot of different things. If you want to understand it meaningfully, you need to understand the individual components first of all, before then understanding how they can fit together. So it is worthwhile exploring, playing about with this. You're free to modify, to use, to extend, to do whatever you want with the thing by way of either using this or adapting or taking some inspiration from it by way of creating your own game. So hopefully of use.